Yes.
Okay, so question 6. Where is it? Where's my pen? Question 6. Coming from here. So we're saying evaluate the following integrals. A, the integral of dx over 1 minus sine x. The integral of dx, integral of dx over 1 minus sine x. So the integrals that involve sine x and squared, no combination of cos and in the denominator with some other things. Here we cannot use substitution method directly like the use substitution. Suppose I tried use substitution. I will have u equal to say 1 minus sine x. And then du will be cos x dx. So we needed cos x. There's no cos x. So it means that you cannot go with that kind of a substitution. And again, you cannot try in this case because, again, it looks complicated. So then what do? We realize that what we need here is a z substitution, which is normally called as the magic substitution, where you would say, let my z be equal to tan of x over 2. So with this arrangement, I will have sin x to be 2z over 1 plus z squared. So what else do we need? We also need dx. So we have a dx to be 2 dz over 1 plus z squared. So now we go back and do the substitution. So we have the integral of dx is 2 dz.
So this is a tan substitution.
This is?
A tan substitution.
Yes.
Right.
So we are dividing this by 1 minus, what is sin x? Sin x is 2z over 1 plus z squared. This is the magic substitution. The heavy magic substitution. It's nice. So we can work out our fraction. We have 2 dz over 1 plus z squared. And then we divide by the common denominator down is that. And then we have over 1 there. So 1 into the denominator, we are getting 1 plus z squared. And then minus 2z. So everything becomes the integral. Of course, these will cancel. So we'll have 2 over z squared minus 2z plus 1 dz. Like that. And so, if we look at this, we have a quadratic in the denominator. So what do? We factorize it. So what could be the factors there? I think there are factors. Z squared, we can use ones as the factors so that we have z minus 1, minus 1, z minus 1. So this is going to be the integral now of 2 over z minus 1 squared dz. Then from there now we can use u substitution. You let your u to be z minus 1 so that you do the du, which will be dz. And then substitute. So we have 2 over u squared du, which can be written as 2u negative 2 du. Then now we can integrate. So we're adding a 1. So we have 2u minus 1 over minus 1, which is negative 2 over z. Now what is our z? Oh, negative 2 over u, sorry. Negative 2 over u to the power 1. Now what is our u? Our u is z minus 1. And what is our z? Our z is tan x over 2 and then minus 1. This becomes the integral, of course, plus c. That's an integral there. Like that. Okay, so I think even the B part is how we said we can do it. It's just the same substitution of me.
Let's do it. So.
Okay, let's check the question. G theta over 3 minus 4 sine theta plus 2 cos theta. G theta. G theta.
So I can't get you.
Hello? Hello? We are saying G theta over.
I can't get you.
Even now?
Hello?
Oh. Hello?
Hello?
Hello? Hello?
Sir,
Yes.
we're able to get now.
Okay. So we are doing B. So we are saying d theta over 3 minus 4 sine theta plus 2 cos theta. Let me check again. D theta over 3. D theta over 3 minus 4 sine theta plus what?
2 cos theta.
Plus 2 cos theta. Okay. Plus 2 cos theta. Okay, so we substitute again. Our d theta, as usual, it's our 2 dz over 1 plus z squared over 3 minus 4 sine theta is 2z over 1 plus z plus 2 cos theta is 1 minus z squared over 1 plus z. So we work out this. We have the integral of 2 dz over 1 plus z squared over 1 plus z squared down. And then we have 3. So I'll be expanding here, I think. Yeah, so it will be 3 plus 3z squared. Let me write it properly. Yeah, plus 3z squared minus 8z plus 2 minus 2z squared. And then when we work out this, what does it become? So of course, this will cancel. So now we have 2 over 3z squared minus 2z squared. That's z squared minus 8z plus 5 dz. So now we look at this. Can we find two numbers that when you multiply, you get 5? When you add, you get -8. Ooh, of course not. Yeah, of course not. So we need to complete the square. The square for this particular one. And then use in substitution that we know. So let's complete the square. So it will be z minus 4 squared plus 1. No. Minus what? 16 plus 5 is negative 16 plus 5. Minus 11. Is it? Anyone saying yes? Are you guys there even? Look, I'm saying z squared minus 8z plus 4 squared minus 4 squared plus 5. So this would be z minus 4 squared. Negative 16 plus 5 is negative 11. So that's the integral that we are going to have now. We have the integral of 2 over z minus 4 squared minus 11 dz. So from there now, since we did question 1, hello.
So it was hard for me to get into the meeting. I'm gonna take my message. I don't know how you're getting the 2dz over 1 plus z squared. I don't know where these are coming from.
So from this one, we are saying whenever you use this substitution, you have these more like identities for the z substitution, where z is equal to tan x over 2, and then sine x becomes 2z over 1 plus z squared. Dx becomes 2dz.
I can't get you.
Hello?
I can get you now.
Yeah, so I was saying we use the z substitution identity, where z is tan x over 2, sin x is 2z over 1 plus z squared, and dx is 2dz over 1 plus z squared, and then cos x is equal to 1 minus z squared over 1 plus z squared. Like that. So these are things that they're not easily, we don't drive them easily whenever we have an integral to make to evaluate. Normally, we just use them direct like this because it can take us some good minutes to drive them. So that's why here we just dropped them and then started solving. likely that you would remember. So now from this stage, yeah, I'll let you finish it. Huh? Use trig substitution. From here. That's fine, is it? We did these things. So it should not be a problem, eh? Agreed?
So just do it.
Mm. Mm.
So just finish the question.
Mm. 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 Ah. Ah. Okay. Now why should I finish it? Okay, what substitution are we making here? What would be our yeah, I thought you guys enjoyed those questions. But let z minus 4 be equal to what? Again, you forgot. Let me bring you back here. So since we have a variable minus a constant. So you pick from here. If we divide, if we take cos or sine, that's a constant minus a variable. So if we divide by cos, we are going to have tan plus 1 equal to sec squared theta. So if we take 1 the other side, we'll have tan squared theta is sec squared theta minus 1, which is a setup of our denominator. It's a variable minus a constant. So it means that here we'll let z minus 1 be equal to a which is root 11 sec theta. I'm trying to show you how not to forget. Then from there now you can have your dz. dz is going to be root 11 sec theta tan theta d theta. So we'll substitute the integral of 2 over root 11 sec theta squared minus 11 root 11 sec theta tan theta d theta. And so we can take 2 root 11 out and remain with sec theta tan theta over 11 sec squared theta minus 1 d theta. And so we know that this is tan squared theta. So we have this integral of integral of sec theta tan theta over tan squared theta d theta. So now this and the power goes. So we remain with 2 root 11 over 11 integral of sec theta over tan theta. Now look at this, sec theta over tan theta is the same thing as 1 over cos over sine over cos. So this is like 1 over cos times cos over sine. So these will cancel. So we're going to remain with 1 over sine. So we have 2, so here 1 over sine is the same thing as cosec theta d theta. Now what's the integral of cosec theta d theta? Anyone remembering? Integral of cosec theta?
Negative cot squared. Or negative cot.
Integral of
I don't
cosec. Integral of cosec is negative ln cosec theta plus cot theta plus c. Then you get back and check what was our theta. So our theta was sec inverse of what? Of z minus 4 over root 11. So you substitute where there is cosec. You put minus 2 root 11 over 11 ln cosec. Where there's theta, you put sec inverse z minus 4 over root 11 plus cot sec inverse z minus 4 over root 11, of course, plus c. That's how the integral comes out. So you must be good at the trig substitution so that when you get to z, because z substitution will take you to any form of integral. It may take you to by parts, it may take you to trig substitution, it may take you to U substitution, it may take you to reduction. So you must be ready for whatever comes your way as you do that. Okay, this is enough for question 6. I should think so. Let's now move to question 1. We now got question 7. Which part are you doing here? Choose one. Hello.
Let's go for A.
We go for A.
A and C.
Oh, it'll become 2 again. Okay. A, integrate x squared tan inverse x. X squared tan inverse x dx. So by parts, you use this guy. From your left, that's your u. From your right, that's your dv. So we according to our left, which is algebra, then no, inverse 3 algebra. So inverse 3 becomes our tan inverse of, and then our dv algebra x squared dv. So when we integrate v, we get x3 over 3.
Dad, I don't know if you're very far from your microphone. I can't get you.
Even now,
Now I can get you.
so our du, we differentiate u now. Our du is going to be dx over 1 plus x squared. Then we do the combination. So we know that the integral of u dv is what? uv minus v du, which is going to be, what's our uv? So we have x3 tan inverse of x over 3 minus, I'll put 1 over 3 outside so that I have x3 over 1 plus x squared dx. So now it remains to integrate x3 over 1 plus x squared. So here, because the power of the numerator is higher than the power of the denominator, we use long division just to break this guy. So we have x squared plus 1 into x power 3. X squared into x power 3, we get x. Do the multiplication. We have x3 plus x. Then we subtract, so we get minus x. So the power of the minus x is less than x squared. So we can't continue with the long division. It means that we are done there. So we come back and divide. We just want to integrate this part. So let me get it here. Say the integral of x3 over 1 plus x squared dx now becomes the integral of x minus x over 1 plus x squared dx. So the first piece, I can easily integrate x squared over 2. But the second piece, we use substitution again. We let u be 1 plus x squared. And then our du becomes 2x dx. Meaning the x dx, so we have du over 2 equal to x dx. Like that. So we can do the integral substitution. That's going to be the integral of du over 2 over u. So meaning this alone, we have x squared over 2 minus half. That will be du over u, meaning I'm getting ln u plus c. So now I go back and substitute. So we have the integral of x squared tan inverse x. The x equal to x3 tan inverse of x over 3 minus 1 over 3 times 2, that becomes 1 over 6 x squared, plus, because it was minus, times minus. So it will be plus ln x squared plus 1 over 2 by 3. That is 6 plus c. This becomes the integral of that particular one. Okay. Then you also said C.
So wait, on the previous question, here after this formula, the integral of u dv is equals to uv. This one here is equals to this.
Hmm.
I'm not understanding that part. Oh.
You mean the formula or the substitution?
The substitution in the formula.
So what is our u? U is this one, tan inverse. V is this one. So we multiply them, uv, they are here. Combined, x3 over 3 tan inverse x, minus the integral of v du. Our v is this one, which has 1 over 3, which is outside. Integral, as the formula says, v, which is x3 now, multiplied by du, which is dx over 1 plus x squared. So we have x3 over 1 plus x squared. Just because one had dx over 1 plus x squared, the other one had 1 over 3 x3. That's why we've multiplied them like that. Numerators multiply, denominators multiply.
Thank you.
Okay. So I'm not so sure whether time can allow us to do C, because we have like 2 minutes.
Sir.
Yes?
Sir, I have a question. Would it have been wrong if we used U substitution?
Where?
Where it's saying 1 plus x squared.
No, you still get the correct answer.
All right, sir.
Where it says x over 1 plus x squared, right?
Yes, 1 plus x squared.
As a denominator
of
x, is it?
Yes.
Yeah, you could still, though we have used U substitution there, so I don't know what you mean. Oh, where you say U is equal to 1 plus x squared.
Yes.
Yeah, you still get the answer to come out in tan inverse form. Okay, so we'll log out and quickly log back. Immediate, the same link.